Okay, so today we're going to be talking about how to convert between moles and grams, and then also from grams back to moles. But before we do that, we're going to review what we've talked about the other day. And we started this concept called moles. Now, this is Unit 6. And moles, what it is, it's a way of counting particles. And moles is the SI base unit for the amount of a substance. Now, we use different uh, things when we're measuring amount. We use grams. And grams we can weigh out in the lab. If I ask you to go weigh me out 20 grams of a compound, you could get an electronic balance and you could weigh that out and it would tell you the amount of grams. We also use this concept called moles to tell the amounts. But the thing about moles is we don't have a balance that can weigh things out in moles. That's why whenever we're in the lab, we always deal with grams. But moles are necessary. You might think, well, what's the point if we can't weigh things out in moles? And it's the same concept of we have different units if we're measuring the length of something. We might use feet, or we might use inches or meters. So these are grams and moles are both ways to express the amount. But moles we cannot weigh out on a balance because moles are different for different substances. A mole of carbon weighs a different amount than a mole of magnesium. So one way we define a mole is 1 mole is equal to 6.02 times 10 to the 23rd, and that could be atoms, molecules, or formula units. If it's atoms, if we're talking about an individual element. Molecules, if we're talking about a covalent compound with two nonmetals, two or more nonmetals. And then we use formula units if we're talking about an ionic compound. But, usually a lot of times we say atoms or molecules, it doesn't matter. So if I have a mole of zinc, it's going to have 6.02 times 10 to the 23rd atoms. If I have a mole of carbon dioxide, it's going to have 6.02 times 10 to the 23rd molecules. If I have a mole of the ionic compound sodium chloride, NaCl, it would have 6.02 times 10 to the 23rd formula units. So that's one way we define a mole, but that doesn't really help us because we can't see individual molecules. We can't pick out a molecule, we can't count them and stuff. So we need another unit besides molecules to be able to measure the amount of something. That's where moles and grams come in. 1 mole can also be defined as the molar mass of an element or compound. Now, moles, they bridge the gap between molecules and grams. So that's one thing that we'll be talking about. There's really no point. A lot of textbooks will have you converting, moles to atoms using this big number right here. However, since we don't really deal in molecules in chemistry because they're on the microscopic level, that's really unnecessary. So moles, really what they do is they kind of bridge the gap between the microscopic, what we can't see, and the macroscopic, which we can. Alright, so 1 mole, is defined as the molar mass of an element or a compound. Well, if we're talking about an individual element, we call that atomic mass, but really we can use molar mass interchangeably with that. So 1 mole of carbon would be equal to its atomic mass. Now, its atomic mass, if you look on the periodic table, we find carbon. The number above is the atomic number. It tells you the number of protons, but the number below tells you the atomic mass. It tells you the weight of it. And it's telling you that in units called AMU, atomic mass units. That's a very small unit. To make things simpler, we just are going to refer to that instead of atomic mass units. We're going to refer to it as grams. So 1 mole of carbon would be equal to 12.01 grams. It's atomic mass, or its molar mass. 1 mole of magnesium would be 24.3 grams. 1 mole of hydrogen would be equal to its atomic mass, 1.01 grams. And we're going to round these atomic masses to 2 decimal places. Now, on your periodic table that you use, they should already be rounded to 2 decimal places. All right, so when we say 1 mole of carbon is equal to its molar mass, well, that's also equal to 6.02 times 10 to the 23rd atoms. If we add 1 mole of water, if we add up the individual masses of the hydrogen and the oxygen, it equals 18.02 grams. And that would be equal to also 1 mole of it, 6.02 times 10 to the 23rd. And since we're talking about a covalent compound, that would be molecules. But just keep in mind, you need to know this number here, but we're not going to be using it to convert any. We're going to be dealing with moles and grams. Now, the reason we have to use moles and we can't just use grams all the time is because when we deal, especially with the next unit, when we're talking about something called stoichiometry, we're dealing with reactions, and we can predict the amount of our products that are formed based on our balanced chemical equation. Now, these numbers, these coefficients here, tell us, and that would be a 1 in front of the O2, that tells us that 2 molecules of H2 reacts with 1 molecule of O2, that's oxygen, to produce 2 molecules of H2O. And I've drawn that out here. 2 separate molecules of H2, and this 1 molecule of O2 produces these 2 molecules of H2O. Well, that doesn't really help us if we're trying to figure out, trying to do this reaction, which you can't count these molecules. So what Avogadro figured out was he could relate something. He came up with moles to molecules, and we could say these numbers here, instead of molecules, we could say these amounts are moles. And by doing that, we can convert these to grams, and then we can weigh out these amounts in the lab with the balance, if we were going to do this reaction like this. But this is the simplest ratio of how this reaction happens in nature. The balanced equation tells you that, so I can use this balanced equation to manipulate amounts, to get a certain amount of product that I want to get. Now, the molar mass is defined as the mass of 1 mole of a substance, and the units are grams per mole. So 1 mole of carbon is equal to 12.01 grams of carbon. It's the same thing. And, so we say the molar mass of carbon is 12.01 grams per mole. Now, example, we've already did a couple of days of molar mass. You should know how to do this. I'm going to work this one example because we're going to be using the molar mass in this new material. So if I'm going to find the molar mass of zinc hydroxide, I need to add up the individual atomic masses that each element brings to this compound. So I'll write down the elements. It's made up of zinc, oxygen, and hydrogen. Zinc, I have 1 atom of it. Oxygen, I have 1 on the inside of parentheses, 2 on the outside. I multiply 2 atoms of oxygen. Hydrogen, I have 1 on the inside times 2 on the outside, gives me 2. What that means is if I have zinc and it's telling me I have 2 of these hydroxides. So I have 2 oxygens, 2 hydrogens that make that up. Alright, I'm going to multiply these numbers of atoms by their atomic masses. I get those from the periodic table. I'll bring my periodic table up. I find zinc, its atomic mass is 65.38. So it'll be 65.38. 1 times 65.38 gives me 65.38. Oxygen is 2 times. If I look up the atomic mass for oxygen, it is 15.999, which would round to 16.00. Like I said, we're always going to go to 2 decimal places. That would equal 32.00. And then hydrogen is 2 times, and it's 1.01. That would give me 2.02. And then I bring up my calculator. And I'm going to add up those masses. So that'd be 65.38 plus 32 plus 2.02. That equals 99.4. So I would go 2 decimal places, 99.4 grams per mole. So what that's telling me is that 1 mole of zinc hydroxide is the same as 99.40 grams. So if I told you, go weigh me out 1 mole of zinc hydroxide, you would go weigh me out 99.40 grams. If I said, go weigh me out 2 moles of zinc hydroxide, you would just multiply 99.40 times 2. And that's what we're going to be talking about today. Alright, so you should have these notes right here, and you should be filling these out as I go along. So when converting between mass, and mass is in grams, you must determine the molar mass to convert. And molar mass will be used as a conversion factor to convert between units of moles and units of grams. Because molar mass is the mass of 1 mole of a substance, the conversion factor can be written as, and so if we're going to write this, when we convert, same thing as converting like feet to inches. You have to know that 1 foot equals 12 inches. It's the same concept. So we have to know that 1 mole over the molar mass of the substance, or the molar mass over 1 mole. We're going to be using that as a conversion factor. So when converting between grams and moles, look at the units to determine if you need to multiply or divide. So when converting moles to grams, we're going to multiply by the molar mass. When converting grams to moles, we're going to divide by the molar mass. So if I'm giving moles and I want to go to grams, I'm just going to figure out my molar mass and I'm going to multiply. So I look at it as if I'm going moles to grams, I'm going moles are smaller than grams. I'm going from mini to grande. I have to multiply. And if I'm going grams to moles, I'm going, grams are bigger than moles. I'm going from grande to mini. How do I do that? I divide by the molar mass. Now, one thing to keep in mind, a lot of students make this mistake, is they don't know if they should take their molar mass and divide it by their grams that they're given, or take their grams and divide by the molar mass. You're always going to take your grams given in the problem and you're going to divide by the molar mass. So in your calculator, you're always going to put in the grams that you're given in the problem at first, and then divide that by the molar mass of the compound or the element that you are dealing with. So if we look at a problem, it says, what is the mass? Anytime it asks you what is the mass, it is asking you for grams. Always keep that in mind. So if it's asking this, you're given in the problem, you're given 0.045 moles of NaCl. You got to remember to find the molar mass first. Our conversion factor we're going to use is our molar mass, so we need to calculate that. So when I add that up, I have sodium chloride, I have Na, and I have Cl. I have one atom of Na times its atomic mass. And if I look that up, if I look up Na, it has sodium, it is 22.99. One times 22.99 is 22.99. And then chlorine is, I got one atom of it times its atomic mass. Look up chlorine, it is 35.45. Now I'm going to add that up to find my molar mass. And I get 58.44. And that's going to be, grams per mole. That's going to be my conversion factor. And what that means is one mole of NaCl is equal to 58.44 grams. That's my conversion factor. That's what I'm going to use to convert. Now, the way I can do this is two different ways. I can work it out where I cancel out my units and I know exactly if I'm supposed to multiply or divide, or I can simply just multiply. So I'll work it both ways and you can decide which way you want to work it. Most students just want to simply multiply it, but I'll show you kind of the longer way, the harder way, cancel out units in case you want to work it that way. So if I'm starting with 0.045, and that is moles. And like moles, we can abbreviate MOL, so I'll write that way a lot. Moles of NaCl. And I'm going to multiply by the conversion. My conversion factor is this right here. Now, either the 1 mole of NaCl needs to go on top or the 58.44 grams. Now, I need to cancel out my units. I need to cancel moles. So if I put the 1 mole on bottom, they cancel, and I put the 58.44 grams on top, and I can always put this over 1 to know that the 0.045 moles are on top. And my moles cancel, I'm left with grams, which is the units I'm looking for, so I know I'm supposed to multiply. I take 0.045. And multiply it by 58.44. And I get 2.6298. I'm going to round that to 2 decimal places. And that would give me 2.63. And then my units I want to write down is going to be moles of NaCl. And that's my answer. Now, that's the way of working it out where I cancel out my units. Now, a lot of you don't want to go through that, and I don't blame you. You might want to do this a simpler way, and where you simply remember that if I'm going from moles to grams, I simply multiply by my molar mass. So I would just take 0.045, multiply that by 58.44. Again, that would give me, and I forgot what I just calculated, 2.63. moles of NaCl. Now if we look at the next example, if a student measured 0.25 grams of NaCl in lab, how many moles does the student have? Alright, so this time I'm given in the problem grams and I want to find moles. Well, I know I just calculated the molar mass in the problem before. 1 mole of NaCl is equal to 58.44 grams, this molar mass. Alright, so if I'm going to work this, if I'm starting with 0.25 grams and I want to convert that, and I can put that over 1 times, and I want to use my conversion factor. Now this time, does the 1 mole of NaCl go on top, or does it go on bottom? Whatever. Well, if I'm trying to go to moles, I need to put the 1 mole of NaCl on top, because that's the units I'm looking for. I need to put the 58.44 grams on bottom. That way my grams will cancel. And now it's 0.25 times 1 is 0.25 divided by, you need to multiply everything on bottom. 1 times 58.44, so that's going to be 0.25 divided by 58.44. And I get that's equal to 0.0043. And I can't really go 2 decimal places. I have to go on out since there's 0.00, 0.43, and my units are going to be moles of NaCl. Now in the above example, I messed up on my units. That shouldn't be moles, that should be grams. Instead, I wrote that down wrong. So in this other case, if you notice, simply, I could have worked through it where my conversion factor But if I wanted to take a little bit of a shortcut, what I could have done, instead of going through that process there, canceling out units, I could have figured out my molar mass. Then I could have taken what I was given in the problem, which was 0.25 grams. Remember, grams to moles, I divide by the molar mass. So I take my grams given, divide it by my molar mass, 58.44, and that would have gave me 0.0043 moles NaCl. So either way you do it, you're going to come out with the right answer. If you cancel out your units, you really don't have to remember whether you're supposed to multiply or divide, because you cancel out units, it will tell you. But otherwise, if you just want to memorize moles to grams, multiply by the molar mass, grams to moles, divide by the molar mass. Now this next problem says convert 1.3 moles of magnesium to grams. So what I need for my conversion factor, and this time I'm dealing with a individual element. So 1 mole of magnesium is going to be equal to its atomic mass. So I'll look it up on my periodic table. If I look at magnesium, it is 24.31. grams. That's how much it weighs. That's my conversion factor right there that I'm going to use. Same things like 1 foot equals 12 inches. So it's a conversion factor that you have to know to be able to convert. And I know that I'm starting with 1.3 moles. That's what I'm given. Put that over 1. I'm going to multiply by my conversion factor that tells me 1 mole of magnesium is 24.31 grams. If I'm looking for grams, I need to put the grams on top. So I put the 24.31 grams over on top, the 1 mole on bottom. That way my moles cancel. And I would take 1.3 times 24.31. That gives me 31.60. And that would tell me, I'm looking at that's grams of Mg would be my answer. Now, if I wanted to take a shortcut on that problem, I simply remember if I'm going moles to grams, I got to multiply by the molar mass. So that would have been 1.3 times 24.31. That would have given me the same answer there. Now our last problem says convert 580 grams of calcium phosphate to moles. So I'm given in the problem grams. I want to go to moles. So I need to know my conversion factor. My conversion factor tells me that 1 mole of calcium phosphate is equal to its molar mass. Now, we work molar mass problems. You should know how to do that by now. You add up the individual masses. I've already done that, and the molar mass of it equals 310.18 grams. So then I'm given in the problem 580 grams, put that over 1, going to multiply by my conversion factor. Now, since I'm going to moles, I want to put the 1 mole on top. I need my grams to cancel, so I put the 310.18 grams on bottom. That way my grams cancel. And then when I multiply it out, that'd be 580 times 1 equals 580. 1 times 310.18 equals 310.18. And then I divide. And I get 1.869, around that's 2 decimal places. That should equal 1.87. My units are, I went to moles, so that'd be moles of Ca3, PO4, 2. Now, if I did it, the other way, I need to remember grams to moles. I divide. I always take my grams given in the problem and divide by the molar mass. So I'd always take, I'd take 580, punch it in first, divided by the molar mass that I calculated, which was 310.18, divide, and you get that same answer. So whichever way you want to do these problems, whichever way is easier for you, do what's best for you. But just always remember, if I'm going grams to moles, I'm taking my grams that are given in the problem and dividing that by my molar mass. If I'm going moles to grams, I multiply by the molar mass. Now, right now, what you should do is these practice problems right here, where you're converting. And I've given you the answers to where you can check those if my answers are right. So work those problems. And, keep in mind, when asking on number 7, what is the mass? It's asking you for the grams, to convert to grams.